Ladies and gentlemen, we move to Chapter 11, Menstrual Abnormalities. We're going to start with overview of menstrual physiology, and this is really important stuff to get. We're going to spend quite a few minutes on this because it lays the basis for understanding what's going to come up in the next two chapters. Menarche. Menarche is a mean age of 12 to 13, and it is when the first menstrual flow begins. It technically signifies the start of reproductive potential, but actually the initial menstrual periods are anovulatory, so reproduction probably will not occur. However, once they become regular ovulations, which is usually within 2 to 3 years after the first menstrual period, then we have the reproductive years, which last basically from 15 to 45. 360 cycles, monthly menstrual flow, and this is a period of reproductive potential. And a lot of what we'll talk about has to do with this period. Menopause is a point in time, on the average age is 51, which is the last menstrual flow, and technically means that there are no functional follicles in the ovary. No follicles that will respond. Now, if you do sections of the ovary, histologically you will find follicles, but they're not functional. This signifies the end of reproductive potential. In your notes, you will see this figure, which looks deceptively simple, is extremely pregnant with meaning. We're going to spend a lot of time on that. We're going to look at the menstrual cycle from the standpoint of gonadotropins, FSH, LH. We're going to look at it from the standpoint of the ovarian steroids, estradiol and progesterone. We're going to look at it from the standpoint of the ovarian follicle and the corpus luteum, and then from the standpoint of the endometrium. And you notice we're assuming here that we have a 28-day cycle. If you understand this figure, you will understand the endocrinology of normal and precocious puberty, which we will talk at, anovulatory amenorrhea, which we'll discuss at some length, anovulatory bleeding, polycystic ovarian syndrome, primary dysmenorrhea, and how oral contraceptive pills work. So let's start. In terms of the layers of the endometrium, you can see that we have a dotted brown line here. This marks the transition between the basalis zone and the functionalis zone. The functionalis zone is a superficial layer which sheds off with each menstrual cycle. When progesterone levels fall, there is spiral arterial spasm, there is ischemia, release of prostaglandins, necrosis, and the functionalis zone sloughs off. The basalis zone is the zone from which regeneration takes place. And the basalis zone is always present. When we look at the phases of the endometrium, we can see we have a 28-day cycle. In the middle, at day 14, is what we assume is ovulation. We start the menstrual cycle with the first day of the menstrual period. The length of the menstrual phase can vary. 3 days, 7 days. The proliferative phase is where the estrogen is primarily dominant and stimulates a proliferation of the endometrium, and it grows. Mid-cycle, we have the ovulation. The corpus luteum produces progesterone, and the progesterone is what brings about the secretory phase. And you can tell this histologically. What's important to remember is that the post-ovulatory phase, the secretory phase, is fixed. It is 14 days. The pre-ovulatory phase can vary anywhere from 7 to 21 days. What is it that determines the length of the secretory phase? It is probably the lifespan of the corpus luteum. And that appears to be fairly stable in most women. Okay, let's look at the endocrinology. The hypothalamus secretes gonadotropin-releasing hormone. that travels through the hypophyseal portal circulation to the anterior pituitary gland. In response to GnRH, the anterior pituitary gland releases FSH. FSH goes into the peripheral circulation and is specifically directed at the ovarian follicle. In response to FSH, the ovarian follicle produces estrogen. And of course, estrogen is a systemic hormone that has many, many sites where it works. The ovarian follicle also produces inhibin, which is a hormone which feeds back to the anterior pituitary and decreases FSH. So we have two hormones which feed back to the anterior pituitary to control FSH. There is estrogen and there is inhibin. After menopause, inhibin is no longer made because there are no ovarian follicles that are functional, and estrogen is not being made, and so FSH levels will rise. When estrogen has been present, and in fact is rising for over 70 hours, well, first let me say the endometrium responds with the proliferation. But when the endometrium has been stimulated for 70 hours with increasing estrogen, that stimulates the LH surge from the anterior pituitary, and that results in ovulation. The site of ovulation becomes the place where the corpus luteum forms, and corpus luteum produces progesterone. Progesterone stimulates the endometrium to produce secretory changes favorable for implantation. If there is no pregnancy, if there is no beta-HCG, the corpus luteum says, why should I keep making progesterone? I'm going to take my toys and go home, and what happens? Progesterone levels start to fall. When progesterone levels reach a certain point, there is spiral arteriolar spasm, there is necrosis, there is release of prostaglandins, and we have the menstrual flow, which is shed out through the vagina. You can see then there are many hormones which are involved in the reproductive process and the menstrual cycle, and we can have problems which arise with GnRH, FSH, LH, estrogen, and progesterone. And as we go through, you'll see how important each of these are in normal menstrual functioning. Okay, let's look at the gonadotropins. The gonadotropins in the first part of the cycle is dominated by FSH. And you can see initially FSH rises, and then it starts falling in the proliferative or follicular phase. There is a rise slightly in mid-cycle. In the last half of the cycle, it is the luteal phase, which is dominated by LH, and notice what happens at mid-cycle. We have the LH surge. Typically on a 28-day cycle, that occurs on day 14, and that is important in order for ovulation and the corpus luteum formations take place. In terms of the ovarian steroids, again, you can see we have a 28-day cycle. The first half of the cycle is dominated by the follicle. The follicle produces estrogen. The last half of the cycle is under the control of the corpus luteum. We call this the luteal phase, and the corpus luteum produces progesterone. And you can see in the first half of the cycle, it is estrogen that dominates. In the second half of the cycle, it is progesterone which dominates. So we have the follicular phase and the luteal phase, estrogen dominant, progesterone dominant. In terms of the ovarian follicle, the first half of the cycle, the follicle itself predominates, and we're preparing for ovulation. In the second half of the cycle, it is the corpus luteum which predominates and produces progesterone. The follicle has two layers of cells. The inner cell layer is called the granulosa cells. The outer layer is the theca cells. The theca cells, under the stimulation of LH, produce androgens. The androgens diffuse across into the granulosa cells, and the granulosa cells, under the influence of FSH, stimulate estrogen production. Would you notice that all estrogens are derived from androgens, and it is the aromatase enzyme which converts androgens into estrogens. The endometrium. In the first half of the cycle, the proliferative phase, the follicular phase, estrogen is the dominant hormone. What you need to know about estrogen is it produces an unstable endometrium. If we have estrogen only, the endometrial lining will thicken and thicken and thicken, and finally it'll become unstable and start shedding off irregularly, as you see with anovulation. Normally, in the second half of the cycle, the corpus luteum produces progesterone, and we have secretory phase, which progesterone is dominant. What you need to remember is that the secretory phase, under the influence of progesterone, the endometrium is stable, and you normally do not have bleeding which occurs in the last half of the cycle. Progesterone stabilizes endometrium, and we'll talk about how later on, when you want to stabilize a woman who is anovulatory, you give her progestins, and that will prevent this irregular, unpredictable bleeding. If pregnancy does not occur and the corpus luteum starts to involute, with decreasing progesterone levels, we have spiral arteriolar constriction, we have prostaglandin release, we have necrosis, and the endometrium sloughs off. The prostaglandin release is what stimulates smooth muscle contractions of the uterus, and this is what we call progesterone withdrawal bleeding. This is characterized by cramping, and the reason there is cramping is because we have prostaglandin release, which stimulates contractions of the smooth muscle of the endometrium, of the myometrium. If you have anovulation, you typically do not have cramping, and that's important to remember. The menstrual phase will then follow as the endometrium sloughs off. This picture is to show what happens with an estrogen-dominant endometrium. It is unstable, and you can see the bleeding is not predictable, it is not regular, it can vary in terms of duration, in terms of amount, and frequency. This is characteristic of anovulatory estrogen-dominant endometrium. What we want to do to stabilize endometrium is to bring in some progestin. Medroxyprogesterone acetate is a common one which is used. And you can see during the time you give progestin, there is no bleeding. It is stabilized. Then when the progestin is stopped, you have a regular, orderly bleed. It does not last for a long period of time because you have vasoconstriction, spiral arteriolar constriction. And you can notice that when we're done, the endometrium has returned closer to what it should be. We give another 7 days of progestin. Again, we have no bleeding during that period of time. We have a withdrawal bleed which is orderly, which is limited, and now we return back to, to our normal endometrial thickness. So we can see the estrogen-dominant endometrium and what happens when we add progestin. We'll talk about this in many different cases. All right, let's see if we can put this all together. Here we have the gonadotropins, here we have the steroids, estradiol and progesterone. First, I just want to point out that the first half of the cycle is also split into two halves. The first half is a recruitment of many follicles, and this is what happens in the first part of the cycle. If there are lots of follicles, such as in a young woman, this will be a longer period of time. As a woman gets closer to the end of her reproductive years, the number of follicles which are available are fewer, and this is a shorter period of time. Typically, there is only one follicle which becomes the dominant follicle, and that is what happens in the last half of the cycle. And you can see FSH initially rises, which stimulates many follicles. When there is a dominant follicle which is selected, notice how the FSH levels actually drop. This is because there is an increase in FSH receptors on the dominant follicle, and you don't need as much FSH in order to get the same amount of stimulation. All right, let's put all this together in a moving diagram. We initially have a rise in FSH. FSH stimulates the follicle to produce estradiol. And you notice estradiol's levels rise. The LH stays pretty stable in the first half of the cycle. FSH actually falls, and yet even as FSH is falling, what happens to the estradiol? Estradiol rises. Now that seems counterintuitive. You'd think if FSH would fall, why would not estradiol levels fall? And the reason is because you have a dominant follicle which has more FSH receptors and a lot of production of estrogen. Notice the estrogen levels are rising. This rising estrogen is important for the LH surge to occur. If estrogen levels are elevated but are tonic and don't change, you will not have ovulation. And that's what happens with polycystic ovarian syndrome. So we have a rising level of estradiol. And if we have a rise from 48 to 72 hours, what happens to the LH? We have the LH surge. The LH surge is a reflection of the rising estradiol levels. The LH surge will result in ovulation. Ovulation results in the formation of the corpus luteum. So the LH surge, ovulation, the corpus luteum, and the corpus luteum produces progesterone. And you notice what happens to progesterone levels. Progesterone levels rise in the secretory phase until about the middle of the last half of the cycle. Then the corpus luteum looks around and it says, is there a pregnancy? Do I need to keep producing progesterone? If there is no pregnancy, if there is no HCG, 7 days after ovulation, the corpus luteum starts to regress. Progesterone levels decline when the progesterone reaches a certain critical level. We have spiral arterial constriction, necrosis, release of prostaglandins, and menses. Now, if you can understand this, you've got a grasp which many physicians will never have. I have had OBGYN physicians who've been practiced for 20 years. When they heard this explanation, they said, for the first time, I understand how this works. So, spend time and get this firmly fixed in your brain. Okay, that's the overview of menstrual physiology.